that's my office mate, Rosie. And we normally don't do photo shoots together, but my brother is a photographer. He never leaves his equipment in the car, so it's often in the house. And in this case, it was a family get-together, and this is my mom's backyard. So that's where that came from.
So hi, my name is Haley. So the standard part is I graduated from undergrad, worked as a software developer for a number of years, went back to grad school, got a master's degree, then went to work for MITRE for I think about 3 years now as a malware analyst and researcher. So aside from that, I'm interested in systems of machines, systems of software, systems of people. I love to observe the component of, say, systems and see how they interact with each other. I mean, clearly, system of people is the most interesting. And a more normal hobby is I'm into quilting.
All right, so here's the outline. I'll be talking about the things on top of the dotted line. So basically the overview of MBC, some of the use cases, its relationship to attack, and then talking about how you actually would use it to do basic labeling or mapping. And then Haley will give some case studies after that. So I would guess many people are familiar with attack. But in case not, it's kind of a basic, you need to know something about it to understand what we've done. So it's a curated knowledge base and model for cyber adversary behavior. And it captures the TTPs and the things that adversaries do when they make their intrusions. And so there's various pieces of attack, but attack for enterprise is where we've kind of spun off of. Those listed there, there's 12, they call them tactics, which are the high-level objectives of the adversary. And so that's kind of where we started from with MBC. And I should say we are not, attack was developed at MITRE. We're from MITRE, but we, in fact, are not connected to the attack project, or we're not on that team. So they're very separate or independent efforts, although related, So, attack is widely used, and it is used currently to capture things, to capture malware behaviors. The best examples are probably, some of the automated sandboxes like Joe Sandbox Falcon. They have their report, and they map to attack. And so, actually, it works really well in many cases, because adversaries, they use malware. The objectives of each or both are obviously overlapping, similar. So for example, if there's a behavior that malware does where it's using command.exe, for commands execution, that would be something that a sandbox might report. It does map really nicely into attack's technique, which is command line interface. But there are some cases when you're looking at malware and you find a behavior that attack doesn't work for, or maybe it's not quite malware oriented enough. The best behaviors in that category are probably the anti-analysis behaviors, such as the examples at the bottom of the slide there. Queries, kernel debugger information, if it sleeps, things like that. So that's where, that was kind of the motivation for developing or defining MBC. So in the fact that, attack doesn't have everything you'd want when you're analyzing malware, we've extended attack. So we've, to date, made 37 new behaviors that are not defined in attack. And as much as that, we've also looked at attack and we've kind of pulled out the things that pertain to malware. Because attack is oriented toward the adversary, MBC is oriented toward malware. And so we've looked at attack, pulled out what applies to malware, and in that way have kind of reduced it so that it's a more focused on malware thing, MBC is. And if you are familiar with attack, those bulleted items in blue at the bottom of the slide, that's kind of the malware-oriented analog for what attack has done. And attack has been really successful, so we tried to kind of emulate and borrow as we could, trying to make MBC, as useful. And so the first thing is that we do maintain, we try to, the malware code-oriented perspective. That's how we're defining things, and that's kind of where we're coming from. It focuses on real-world behaviors actually identified in malware. What that means for us is that we looked at reports that people were putting out, analysis results from malware analysis tools, and we're looking at those exact behaviors, and we want to be able to capture those. And that's something that ATT&CK has done. One of the main reasons I think ATT&CK has been so successful is it's really tapped into the real world. It's made itself very useful because it pertains to what you're actually seeing. So we've tried to do the same with MBC. And then the third thing is, trying to maintain a level of abstraction that works for the malware analysis use cases that we're looking at. So in terms of the use cases, the most obvious is, first on the list, standardized reporting. So if you're able to, you find your behaviors, and that's what you want to find out when you're looking at malware. And if you have some consistent way of capturing those, that's going to make it, you've got this standard way of doing it. It's going to make it easier to actually use the content of the report for detection, mitigation, or whatever. On a related note, you've got the correlation of results. And so you may have, 3 different analysis tools that are giving you reports, and you look at them and you want to be able to say, are these 2 or 3 tools saying the same thing? Are they conflicting, or what? And being able to, if MBC is what they're mapping to, so you've got the same behaviors, they're talked about in the same way, you'll know that, okay, yeah, this is, we've got some correlation here that validates the results, or maybe it's going to point out that you don't have some agreement, in which case it's an area for, further research or further study. It also can be used for creating labeled data sets for malware research, where you get, a bunch of malware, you tag it with MBC, and now you've got, if you have a repository where you've got malware that's tagged in terms of their behaviors, actually, of course, that would be very useful in numerous research efforts. And then finally, MBC supports actual malware analysis, and that's because, as we'll get into, there's a structure involved, there's the higher level objectives, lower level behaviors, and having those in place and things well defined, it helps the analyst because it helps them know what are they looking for, maybe how they know when they found it, how it can be captured, so it kind of guides analysis in that way. So this is, these are those high-level tactics that I listed on the slide about ATT&CK, and that's where we start with MBC. And those are, they call them tactics. We've moved toward objectives that seem more natural to us in talking about malware. And so for the most part, we've used those that they've defined, with the exception of, initial access pertains to how the malware got onto the system. And, we're focused on the code in the malware. So unless the malware itself got itself there, and that's not what initial access generally means for attack, that's kind of outside our scope. So we've graded out there. That's not one that we map to. But the ones in blue are 2 new ones that we define in MBC, 2 new objectives, and that they're both related to anti-analysis behaviors, either behavioral or static. And so we've got, the objectives are the high level, what malware is trying to do. And then kind of the layer down is the behavior, or as ATT&CK calls them, techniques, but the behaviors of how the malware is doing that. And so there's sort of 4 ways relative to ATT&CK that we define things in MBC. So I've got all right, so the first is just as a reference, and that's probably the most common thing that happens in MBC. We look to ATT&CK, it's something that does apply to malware, and so we're basically just creating a wrapper pointing to that attack technique. We don't want to replicate ATT&CK's content. We assume that a user of MBC is going to use ATT&CK. I mean, that's where they're going to go for the information that pertains. And so that's the most simple way that we create a behavior in MBC. And then also at the bottom, called enhance, it may be that there's an attack technique, but it's not quite focused on malware. In that case, we provide additional content that is malware focused. And then, there's that content in addition to the attack content that the user of MBC would use. So for example, with the execution guardrails, that's a technique that ATT&CK defines under defense evasion. We added more to the definition, some examples, and when we were done, it also then applied to the anti-behavioral analysis objective. So we've kind of extended attack in that way. The third way is, we refine some techniques sometimes. So attack will define a technique, and it's a little broad for what we need for malware analysis, and so we'll maybe break it into two pieces. I don't think we've done it more than two pieces where we define two separate things that we think, support malware analysis better. So for example, with software packing, we kind of broken into two where we have a separate behavior for compression and then another behavior which is for obfuscation, which includes like encoding and encryption and more. And then the fourth way that we define behaviors is, those things that attack does not have. So for example, Sandbox Detection, that was something that we defined in MBC as a new behavior. And this kind of it gives a kind of a overall view of the numbers of behaviors relative to attack, and just to know what's what in MBC. So each of the objectives are listed, and then there's 3 numbers shown. And the first number are the number of behaviors in MBC for that objective. The second number are the number of techniques in attack for that, they would call it tactic. And then the last number after the dash are the number of new things that MBC has defined. So for example, with execution, you can see that there are 21 behaviors in MBC. Attack had 33, and that's that. You can see we reduced it. But then of the 21, 6 are new. And you can also see, like for anti-behavioral analysis, it has 12 behaviors. Attack has 0 because they don't define that tactic. But only 10 of the 12 are new because, in fact, in the last example that I think it was the execution guardrails, we borrowed that from attack, and that's one that is kind of repurposed. This is an example of what the actual, all of MBC right now is just on GitHub in Markdown documents. So this is an example of a behavior page, dynamic analysis evasion. So you can see we've got our ID, which we use similarly to what they use, how they use them in attack, the objectives that it pertains to. There's a short description, and we have also methods, where methods are, it's a specific implementation of a behavior. So it's kind of a refining further the higher level behavior. So it's kind of like the third level down. And then not shown, we'll typically have a table of malware samples or examples that exhibit the behavior, and then references and that. So, and as far as labeling and mapping, it's flexible whether you map to an objective only, a behavior only, maybe a combination objective behavior pair. It just, because you're not always going to know, the higher level why, or maybe you won't know the how it's being done. So for example, with a code snippet, this example at the top, it's pretty explicit. You've got the actual code that you're looking at. It's anti-behavioral analysis. You can see what it's doing and that you're trying to detect a debugger. And then there's even a method because you can see that you're working with the process environment block. So that's the most specific you would map to. And then some of the automated tools, they'll have, they write signatures that are identifying behaviors. And so the middle tier there is, ideally the person writing the signature will do the mapping to MBC. And for whatever reason, whatever they're finding in their analysis, they know it does command and control. For example, they may not know, so it's like, why they're doing something. They might not know the lower level details, or maybe it's from a combination of things. So they may just map to an objective and nothing more. Or the other example, they might know the objective and the behavior. And then it's kind of funny, the last example up there for how something is mapped, because it's ideally the person writing the signature is going to map to MBC. But we've got, actually at MITRE, one of the groups I work with, they're kind of the second party. They're getting reports from tools. They're looking at the signatures or the behavior indicators that are being reported on, and then the vendor has not provided the MBC mapping, but they're trying to do it themselves. And so, you know, they'll see something like download, and it's not really clear exactly what that means. So it may be that you end up kind of mapping to 2 different MBC objectives or behaviors. And again, it's not great, but it has reduced it down quite a bit, so you know much more narrowly what might be happening. And so, and this is, I think, a good example of, you know, how MBC helps if you're looking at malware. This is a report that McAfee wrote on Web Cobra. It's an analysis report. It's a really nice report, well written, and it's great because they've identified behaviors and mapped them to attack. And so what I did is I looked at the report and I looked to see, well, if they would have used MBC instead, how would things have changed? And the behaviors listed or shown in black would just be the same. You know, they found them, mapped them to attack, made sense. But there were some cases where, because of the descriptions, either they were missing kind of malware-specific focus or whatnot, they had mapped to things that really, I think, weren't mapped as accurately as they could have been. But again, MBC adds the content, it makes it more about malware-focused. And so those things in purple are the behaviors that, with the additional MBC enhancements, seem like they kind of fell out as a good way to map. And then finally, in blue are the behaviors that they actually, in the report, they were really explicit and they found these, you know, things that were going on, but there wasn't anything in attack to map them to, but MBC had those, and so those are now in blue. I think now Haley is going to talk about some case studies.
Okay, so as Des mentioned, that MBC have 4 uses, and I'm here just to present case study on the bottom 2, which is how to use MBC to label malware and how MBC can be used to inform an analysis process, and hopefully to demonstrate why MBC is needed and how to use it. But before I get into that, so let me talk about my research a little bit to say why we needed MBC in the first place. So my research, I and my partner, not Des, had a research on evaluating various malware similarity detection. And we want to answer questions like, given a method, given 2 samples, why did this method group or not group the 2 samples together? And do we want them to group together or not? And so for that, we need to understand the malware very deeply. And none of the published data set enable us to do that. So then we go about creating our own ground truth via manual analysis, which, as many of you know, is a tons of work. It takes days, if not weeks, to analyze like 1 sample. So anyway, then we want to maximize all that investment by like capturing our knowledge. So then it ends up in this like very long verbose report, but we also need to be able to kind of query them in a meaningful way. So we figure we have to tag the malware, hence the report, with something that is descriptive of the malware itself. So Des and I both work at MITRE, so naturally we got connected, and I learned of MBC. So to me, MBC is provide language to describe malware behavior. Essentially, you know, what does this malware do, and can even give you details of how it does it. To me, is when you think of a malware, that's the first thing you think of. And I found that, you know, MBC language to be succinct and high level, just good, you know, short. It contains a variety of malware objectives and behavior, which means it can describe a lot of things, so that's also a good thing. Now, as some of you know, attack is also a MITRE effort. There's people, as Des mentioned, also use attack to attack malware. So what really pushed my team to use MBC as opposed to attack, because MBC provide tagging for anti-analysis. So anti-analysis techniques, brain drain, they are designed to consume your time, like analyst time. Like for those who haven't done deep dive analysis or don't know what anti-analysis mean, here's just sort of like an imprecise description. They could range from something like code obfuscation, that just basically make the code hard to understand, so you can't figure out what a malware does. There are tools like the OLLVM is designed to create code obfuscation. They could also be basically features in the malware whose sole purpose is to make some of the analysis tools not working or not working properly. So if your tool doesn't work, it hinders your understanding of that malware. Now, there's currently no coherent strategy in dealing with like a variety of anti-analysis techniques. It's all dealt with on a case-by-case basis, up to the skills and experience of the analysts themselves. And I believe that we need to improve our analysis tool to kind of automate the defeat of the anti-analysis techniques to make like one big real progress toward dealing with malware. But in order to do that, we need data. We need data labeled by anti-analysis. And right now we don't have that. So hence, having language to describe anti-analysis is very important. So, all right. So anti-analysis techniques are evil. Tagging them is also not easy. So, I mean, thankfully, MBC actually have rich language to describe them. You have two objectives, anti-static analysis and anti-behavioral analysis. Under each, you have a long list of behaviors. Under the behavior, you got the methods. Now, each of these methods kind of differ considerably in code and observable indicator. And by that, it means if you were to go about, devise a way to detect them or defeat them, that way is going to be different for each of the methods. Some of the techniques are hard to capture. They're hard to capture because it involves complex code logic. It's hard to understand, then it's hard to explain. Now, if you were to label something and then send it out to the world, you need to be able to explain that and convince another person that, this is what it is, this is what happened. It's definitely easy to miss if you don't expect to see it. Like, not every technique is going to defeat everything. So let's say an analyst came across a technique, but it didn't defeat anything in their environment, they wouldn't notice it. So to them, it's some weird piece of code, but it has nothing to do with the functionality of the malware. So I'm just not going to capture it because I don't know what it is. And definitely on the long list of things that you produce from analyze the malware, figure out how anti-analysis techniques, like what they are, how they work, is definitely low on the list. It's under things like figure out, pretty low on the list. So it's very hard to capture. We pretty much expect that, or rather accept, that we won't be able to capture every anti-analysis there is, but we aim to capture as much information as we can. So in our research, we decide to tag the anti-analysis via like the method to the most granular level of details MBC allowed, which is something that we haven't done for the other objective. So, okay, so here I'm just going to go through some of the sample that I and our team have analyzed, just because language is only useful if everyone agree on how to use it. So just some example. Anyway, so first we have a RAT. Basically, it's a custom remote access tool. Because it is a RAT, it is tagged with impact remote access. Impact is the objective, it's all in all cap. Remote access is the behavior. Now this RAT, part of beaconing is, it go and find a list of installed AVs on a victim host and then send it to a controller. We tag that with discovery, security software discovery. Again, discovery is the objective, security software discovery is the behavior. Now note that some of the malware, what it does is see, is there any installed AV here? If it is, quit. This one, just send it to a controller. The controller have by the controller, I mean a control server which someone else operate. The person behind that have the option of like, hey, there antivirus here, let's just kill it. But their intention is outside of the scope of the malware. So we just only tag it with discovery. If the malware decide to do something on that information, we would have tagged it with defense evasion. So the RAT support many commands. I think two of them listed here. One is called the runf command, as you expect. Run this command. That's what it is. So upon receive the runf directive, then the malware call create process to run the command. So we tag it with execution through API. Execution through API indicate that it's used an API like create process. It's also tagged with execution remote command because it's received a remote command. Execute in gray there is actually method. We don't actually tag it with execute, but you can. And then there's also a delf command, which then tag with execution remote command delete file. So this RAT has a big global array where it contains runtime configuration. It contains things like error messages, encryption keys, and things. And this global array is then decrypted at the beginning of its run. So this is an anti-static analysis technique. It's called fall under executable code obfuscation behavior, and via encryption being the method. It's also construct literal string value by moving character into a buffer out of order. So for those who have written code, you could just define a string and save in a variable. What the malware does, create an array of character, moving one character at a time, but then also move them out of order. So if you just look at the code, there's no way you see the resulting strings. So MBC provide a method to capture that called stack strings. And then now the RAT also contains like several core functions that is also encrypted. And it can only be decrypted by a key that is sent from the control server, if the controller, the operator, choose to send it. And then if it's received that key, it decrypts the code, run the code in memory. The code is never saved to disk, like ever. So clearly, the code remains safe, it remains encrypted on disk, which is undercover by the first tag there, anti-static analysis. But because at time it's also remain encrypted in memory, this is where I found by perusing MBC, trying to figure out like, oh, what described this, and I found that having code encrypted in memory is a way to evade memory dumped. So this is sort of an example of like by using MBC, you learn something in return. So this RAT also have anti-analysis, surprise. So this is an example of like why is it hard to capture anti-analysis. So there's a piece of code there that I've kind of circled in 3 places because the code is split in 3 places. But it's I'll call the select function, and WSAFD is set function, which is both does the same thing, but one of them belongs to WinSock library and the other belongs to WinSock 2 library. Normally you use one or the other one, but like why would you ever use 2? So the malware will like call both, check if they agree with each other. If they don't, sleep, and then try calling both again. And I read that and was like, well, what is this? Like, is this even anti-static analysis? Is this some developer just being overly cautious? Don't know. And it's typically not a problem on standard installation with Windows. Chances are you would call both of them would agree with each other, the code works all the time. And then obviously somehow, for whatever reason, if the 2 API don't agree with each other, they're not gonna agree with each other the next time you test for it. So like, what's this? And it also doesn't help that the code is split in 3 places that's kind of far from each other. So as an analyst, you gotta have to scroll back and forth and you follow the connection. It's just hard to see. Whereas there's a dense tree right in the middle of them that actually contain all of the big code, like the core functionality of the malware. So as an analyst and you press for time, you're trying to figure out like what does this malware do, you pay all the attention to that. And by the end, you probably forgot about this weak code you see in the first place. So because this is sort of my research, so I spent time delving into it. So just more picture here. So they do the test of the 2 calls. If they don't agree with each other, they essentially call clock and then call sleep, then call clock again. And what they're trying to do is measure the number of CPU cycles that have passed to a known amount of sleep. And I deduce, this is entirely subjective, I deduce that calculation can be done to see what is the CPU rate R. And so if the value is sufficiently high, the malware restarts itself. And by that I mean it restarts the main function. It's called beaconing again, it goes through everything. If the value is too low, it just repeat the test again. And if the value is somewhere in between, it sends a value to the control server and then repeat the test again. And so I asked myself, and also again perusing MBC, looking at like what can describe this. Now MBC didn't really give you something explicit like pertain to every situation in this case, but I did find that there an emulator evasion technique that involving making the code loop so much that the emulator just quit. And I deduced that this is a case where it's both problematic on an emulator. If you run it through a debugger, essentially you run on like a real machine or VMs, you wouldn't have like the repeated loop. It's only an emulator that somehow forget to emulate one of the function. That's when you get that. And that's how it divides the infinite loop to kill the emulator. So again, I've learned something, and this is I've chosen to tack with anti-behavioral analysis, emulator evasion via extra loops, time locks. Okay, so this is a different malware. This is going to be a lot shorter this time. But anyway, so this is the malware where there's an original sample. Then it drop another sample and then execute that sample. Now we know that malware author can basically sell their malware as a service. There could be 3 different people who write the 3 code. And we want to tag them in the malware that you wrapping, like forwarding input, output, and error pipes to a control server. One of the cases is a reverse shell. Like there's a reverse shell that just wraps some forwarding pipes to and from rat since it's used command prompt. It's also tagged with execution command line interface because it's used command prompt. But the victim program doesn't have to be a shell. And obviously the behavior of this malware is going to include all the function and limitation of that victim program. So what do we tag this with? And again, we want to tag it so that the sandbox tells the same story at the other analysis process. So anyway, in summary, most of the time I found using MBC is straightforward. They have a lot of behaviors, obviously a lot more methods. But the behavior, because they group under different objectives, and sometimes you can kind of get a sense of what are the objectives, so that kind of help you narrow down what behavior you look at. I mean, I think for reference, it contains something like 260 plus behaviors. Guys analyze the method they don't know about. I sometimes have free time and just kind of perusing through all the catalogs. And it helps standardize the language analysts use to talk about malware to each other. And this is important because malware essentially is code. You can write pages and pages about a piece of code. So you want to talk about it in like, transfer information efficiently. So you want to standardize your language. And the last one might be a personal bias for me, but I think having method for anti-analysis objective is great. Anyway, so Des is gonna talk about our forward direction.
All right, so going forward, what are the next plans or steps for MBC? Recently, we converted or translated the markdown into now MBC is available. I don't know if it's available publicly yet, but it's in the sticks to JSON format, which will help with using it in an automated way. One of the things it enabled us to do was to use the attack Navigator, and that's the picture of it right there. It's basically an interactive matrix that attack uses. We are now using it for MBC, and it's nice because it gives you an overview of all the behaviors in their column according to objective. By the end of the calendar year, we're hoping to get, or we should have an MBC website up, which will be much nicer than the markdown that it's in currently. And then kind of longer term, what we'd really like to do, but be some manual effort involved there, is to create a repository of code snippets so that for every behavior in the catalog, there'll be a specific, or not, there'll be at least one or more examples of how that behavior is implemented in code. And then otherwise, there's a few organizations that are using MBC now. Of course, we'd love for more people to be using it. We'd like to expand the community. The feedback and refinement that we've got from people actually using it has been really good, and I think the thing that's making MBC useful. So if you are interested in contributing or just finding out more, we have a discussion list that you could join. Just send an email to mbc@mitre.org. And then for now, though, all the content is in GitHub. There's the link there under MBC project. And we've got, so we've got the markdown documents for the behaviors. We've got, READMEs for all the main sections. And then we actually have a really long FAQ, which it covers things like, the basics of MBC, how behaviors were defined, its relationship to attack, different use cases, how you use it. So there's that. And then, if you do have content or suggestions or whatever, use the GitHub stuff to let us know that, and that'd be great. So, any questions?
When you foresee, or is there a possibility in the future that MBC will officially be a part of the attack framework?
I could not say either way. I mean, at this point, we did talk to them, of course, a couple of years ago, asking, how about defining this and this and this to help with the malware? They have really taken off. A ton of people are using attack, but they can't expand for all the use cases. We weren't the only ones asking them to do something more and something more specific. So at this point, there is no plan, but who knows? So I don't know in the future what might happen. Yeah.
What I heard from the attack team is that their prime focus is on ATT, and whatever is asked from the real sample of attack modeling. What is the scope of your work here? Are you intended to follow that kind of list, or are you intending to have an exhaustive list of all the malwares out there?
We're not, as far as we would like to be able to represent the behaviors of all malware out there. But we're not really like attack, kind of emulates, they look at the stages of the kill chain. Malware doesn't quite work like that. So ours is really code focused, and so it doesn't have, I don't think, that same kind of chronology or linear aspects of what you would see in an intrusion, and that's what attack kind of covers. But the why malware does something does still apply. So it does that because it's trying to be persistent, or it does that because it's trying to make lateral movement, or so it still applies. And what we want to do is, from a code perspective, look to see what the malware does, what is the behavior that it does, how is it doing things, those are the behaviors, and then the why is that higher level structure that attack has. But it doesn't quite flow in the same way. I don't know if that answers.
So in terms of the coverage of the volume of the malware that are out there, what percentage of them are already modeled in your, do you have any estimate?
I have no idea, no. I mean, we've looked at, like that web cobra attack I showed you, we've looked at lots and lots of reports trying to make sure that everything in those reports were covered. We have, it's not a huge database now. In GitHub, we've got maybe 30